Welcome back, everyone. It's Dr. Linder again, and we're going to be looking at continuing with the endocrine system. And in this portion, we're going to take a look at the connection between the hypothalamus and the pituitary. There's an intimate connection between the two because the hypothalamus just doesn't produce ADH and oxytocin that I said on the other slide, but they also produce regulatory hormones. They produce regulatory hormones that are released. And these regulatory hormones are either referred to as inhibitory or releasing hormones. So you may hear of like thyroid stimulating hormone or thyroid inhibitory hormone, or follicular stimulating hormone, or follicular inhibitory hormone. So it's really like an on or off switch to give you an idea, these regulatory hormones. So in this case, the hypothalamus is releasing a hormone that's going to go to the anterior lobe. So the anterior lobe, you see me circling it here, is also known as the adenohypophysis. The adenohypophysis. Whereas the posterior lobe is sometimes referred to as the neurohypophysis. The neurohypophysis. So the hypothalamus sends a message to the adenohypophysis, or the anterior pituitary. And the anterior pituitary, you see right here, is releasing ACTH. Now let's go to the key on the upper right, and we'll see that ACTH stands for adrenocorticotropic hormone. ACTH, adrenocorticotropic hormone. Now, if we break down the word, we can try and figure out where it's going to go to, right? Adreno for the adrenal gland. And in a previous video, you heard me say that the adrenal gland has an outer portion called the cortex, and it has an inner portion called the medulla. So adrenocorticotropic hormone is going to go to the cortex. Cortex means bark, like the bark of a tree, the outer protection of a tree. That's what cortex means. Even when you look at the brain has a cerebral cortex. It's the outer protective covering of the brain. So the adrenal cortex is the outer part of the adrenal gland. The medulla is the inner portion called the adrenal medulla. And both of them are going to produce different hormones. So the adrenal cortex, we see, is pushing out glucocorticoids, and it pushes out what you heard me mention before called mineral corticoids. Mineral corticoids. Now, what's the mineral? The mineral corticoid was what we called aldosterone. Aldosterone. And aldosterone was trying to help the body retain sodium. Think of salt, right? When I think of sodium, I think of NaCl, which is sodium chloride, which is salt. Okay, and if you hold on to salt, or you retain salt, whenever you hold on to minerals, you hold on to water. If you hold on to minerals, you hold on to water. If you hold on to salt, you hold on to water, your blood pressure goes up. Okay, so the adrenal cortex is stimulated to push out glucocorticoids, such as cortisol, cortisone, corticosterone. And what are these going to do? Well, you see the word gluco in there. They're going to be involved in raising your blood sugar. Look at cortisol. Cortisol is produced when you're under stress. Think of what happens after, let's say, You eat dinner at 7 o'clock, you go to bed by midnight, and at 3, 4 in the morning, your body's been in a fasting state. Your body hasn't eaten any food, it's under stress. Your body starts to produce cortisol, and it allows your body to make sugar for ATP production, for energy. So your organs work and your heart beats while you're sleeping. You can still digest your food. So that's the glucocorticoids. The inner portion, it's called the adrenal medulla. Now notice there's no connection from the hypothalamus there, okay? It's going, I'm sorry, there's no connection to the pituitary. Here, your brain is sending signals directly to the adrenal gland. Here, the hypothalamus, part of the brain, send messages to the pituitary and then to the adrenal. Here, the hypothalamus is sending signals directly to the gland itself, to the adrenal medulla, and it pushes out epinephrine and norepinephrine, which is adrenaline and noradrenaline. This is going to make your heart rate go up, right? Your blood pressure go up, your breathing go fast, your pupils dilate, your cholesterol is going to go up, your blood sugar is going to go up, your heart rate goes up, okay? As it does with the adrenal cortex as well, except this is going to happen much quicker with the adrenal medulla. Okay, let's look at another pathway going from the hypothalamus to the pituitary. I'm sure that the hormone that's going to go here to here, we'll call it thyroid releasing hormone, TRH. So thyroid releasing hormone goes to the pituitary. The pituitary then releases thyroid stimulating hormone, which we see here, TSH on the upper right, thyroid stimulating hormone. The TSH is going to hit the receptor on the thyroid gland, and the thyroid gland is going to push out T4, which is thyroxine, and T4 is going to get converted into T3. Some of the conversion takes place in the thyroid, but as I said earlier, most of it takes place in the liver, and it is selenium dependent. Okay, so a lot of people don't think of the mineral selenium when they're having a hypoactive thyroid. Many people aren't thinking maybe there's a liver issue, but thyroid problems are not just about the thyroid. They could be about the conversion of producing T3. Maybe there's an issue with the liver. Maybe you're deficient in selenium. Maybe you're deficient in tyrosine. Maybe you're deficient in iodine. Okay, you need all the ingredients to make a cake. If you don't have enough flour, you don't have enough eggs, you can't make the cake. Okay, the hypothalamus can send messages to the pituitary. The pituitary pushes out GH, which is growth hormone. Growth hormone goes to the liver, and the liver produces something called somatomedins. Somatomedins are going to be the byproduct of growth hormone, and they're going to affect your bones and your muscles and all the other tissues to rejuvenate them and to rebuild them, to make them stronger. Most of the growth hormone is produced when you're sleeping, especially after about 50 minutes of sleep. Your body pushes out a lot of growth hormone. That's why many athletes take a power nap. This is why babies nap so much, right? Because they're growing so rapidly. Every time they nap, their body pushes out growth hormone. The pituitary can push out PRL. PRL is prolactin. When we look at the word prolactin, it looks like prolactation. So PRL, prolactin, goes to the mammary glands to help with milk production. Now we have FSH and LH. We can see FSH is for follicle stimulating hormone, and LH is luteinizing hormone. And you can see that FSH and LH are going to affect both the male reproductive and the female reproductive. So when when FSH has impact on the testes, it's going to be involved in testosterone production and sperm production. Same thing with luteinizing hormone. When we look at FSH, follicular stimulating hormone, it's going to be involved in producing the female sex hormones, estrogen and progesterone. Now, LH, luteinizing hormone, in women, this is involved with ovulation, meaning in the ovary, this is where the egg is formed. And when LH or luteinizing hormone levels rise, it builds up the pressure and the egg is pushed out of the ovary into the fallopian tubes or into the uterine tubes. And this is what is checked when a couple is trying to plan a pregnancy. A woman will pee in a cup and then she'll dip the litmus paper in there and she'll say, "Oh my gosh, I'm ovulating," and that's because luteinizing hormone is really high. That means there's like a 24-hour window for a woman to get pregnant because that means the egg is now moving in the fallopian tubes and the sperm needs to fertilize it quickly in the fallopian tubes for fertilization. Luteinizing hormone in the male is involved in ejaculation. It's involved in helping the smooth muscle contraction in the vas deferens, aka ductus deferens. Okay, then we have melanocyte stimulating hormone, MSH, melanocyte stimulating hormone. They're a little bit uncertain as to what it does 100%, but there is some involvement in the neural system, especially in the brain, and it is involved in skin pigmentation. Now, on the neurohypophysis, on the posterior lobe, this is where oxytocin and ADH have an impact. Oxytocin is going to make the smooth muscle of the female uterus contract. And then oxytocin is also going to affect the smooth muscle of the vas deferens during ejaculation. It's going to work in conjunction with luteinizing hormone. ADH, anti-diuretic hormone. Well, you know what a diuretic does, right? Diuretic makes you go to the bathroom. Coffee is a diuretic, makes you pee, makes you urinate. Alcohol is a diuretic. High blood sugar is a diuretic, right? That's why when people are diabetics, they're peeing many times throughout the day to try and get rid of as much glucose from their system as possible because glucose in high concentrations is very toxic. An anti-diuretic is going to have the opposite effect. It's going to help the person retain water. It's going to help them hold on to water. If you hold on to water, you hold on to minerals. If you get rid of water, you lose minerals. Think of people that take diuretics. Think of the older woman, older yaya, the grandma, walking around in the slippers and her ankles are very puffy and very swollen. They say she's retaining water. They put her on Lasix, which is a diuretic, and it helps the ankles go down because she loses the water. But the problem is when she loses water, she loses sodium, she loses magnesium, she loses potassium, she loses a lot of important minerals, which many are electrolytes, and then you start to get heart irregularities, mental confusion, a lot of issues happen, which is why they try and make diuretics what they call potassium sparing diuretics, where they try and hold on to potassium. Magnesium and potassium like to move together. Okay, so let's just review. So growth hormone is going to stimulate the liver, the muscle, cartilage, bone, and other tissues to secrete what's called insulin-like growth factors. Not insulin, but insulin-like growth factors, which turn to promote growth of body tissues, right? It's going to allow muscles and bones and cartilage to regenerate and repair. Thyroid stimulating hormone, TSH, its target tissue is going to be the thyroid gland, and it's going to stimulate the synthesis and secretion of T4 and T3, which are pretty much involved in your metabolism. You've heard of a hyperactive thyroid or a hypoactive thyroid. Hypoactive is the person who just looks at an ice cream sundae and gains 10 pounds, and the hyperactive thyroid is the one that can eat everything and never put on a pound. FSH, follicular stimulating hormone, and luteinizing hormone are going to affect both female and male reproductive. FSH in the female, it's going to initiate the development of the egg, and it's going to induce the ovarian secretion of estrogen. In the male, it's going to stimulate the testes to produce the sperm. That's follicle stimulating hormone. Luteinizing hormone in the female, it's going to help with the stimulation and secretion of the estrogen, progesterone, ovulation. In the male, it stimulates the testes to produce testosterone. Prolactin, prolactation, promotes milk production. ACTH, adrenocorticotropic hormone, it's going to the adrenal cortex to produce glucocorticoids, mainly cortisol. And then MSH, the target tissue is going to be the brain. They don't know exactly, it says the exact role is still somewhat unknown, but it's going to have some influence over the brain activity, and it can cause some darkening of the skin, right? So these were all your anterior pituitary hormones. The posterior is only two, right? It's only oxytocin and ADH. Oxytocin is going to act on the uterus and also the breast tissue. It's going to stimulate the smooth muscle of the uterus, called the myometrium, for childbirth, for delivery, and it's going to work on the mammary glands for milk ejection. Antidiuretic hormone is designed to conserve body water by decreasing urine volume, decreasing water loss through perspiration, and it's involved in raising blood pressure by constricting the arterioles, right? Making these more narrow. Okay, we'll take a break. When we come back, we'll talk a little bit about homeostasis and feedback loops.